Hello everyone and welcome to Computer Graphics online session. This is a compensating online class. It's gonna be this is gonna be posted actually on YouTube. So in the future, guys, I hope that you are not gonna be thrown off by the style, because it's completely informal, completely unofficial, yet more fun. So it's a little bit different than the regular materials which I usually post. I suppose that you already have watched the following materials before you actually get started. So if you go to the YouTube channel and you go to the videos and we go to the playlists, and I believe computer graphics is somewhere here. Oh, there you go. And I suppose for the future guys who are attending, who are actually watching this, you have to watch part 1, OpenGL part 2, waves and drawings and forms, introduction to GLUT. Today, actually I will not work on the analog clock live because it's already existing there. I will introduce GLUT again for people to show off some stuff. Push and pop matrices, we're gonna have to do that as well. We're gonna do it live today, and we're gonna do also other things. All right. So for this online session, we're gonna have like 4 sessions. This is going to be like 4 hours long, so we're going to break it up into 4 sections, and you're going to see on YouTube there should be, or there hopefully going to be four different videos: session 1, session 2, and session 3. Depends on the breaks which we make. Okay, so let's get started. Now I actually grabbed the same project which we work on during the classes. And the latest thing which I have, probably it's a little bit outdated. If I hit Control F5, I have this random point generator, and it's also squares and everything. So it's quite a very easy program. And since I haven't covered it on the materials, I will just go through the application real quick, and or the classes which I created real quick, and then I can move on to the next set of features we would like to implement before we get on and go ahead and work. So what we basically have done here, I've created a small, I have already a small vector 3D class. You have it already in the materials. You can use it. It's already in the PDF in there, so you can just copy paste the code. That's what I've in fact done. And I have a small vertex class that describes the position of that vertex in vector 3D, and has a color, which is a class that I have defined right here. So that class contains R, G, and V. And you can just simply construct an object of a vertex color by just simply calling the constructor either the default one or the full default constructor. So basically what I've done here is whenever I try to let me hit F7 here, I just created a small function that just simply generates points that are positioned between in the range of -1 and 1. So I created a vertices list here as a global variable, and I have I've actually called it right here when we constructed. So I've created a new list, I initialized it here, and I call the function right when the form starts. And here random is a class that is exists already in the system namespace, and I've just simply created for every amount of count. So I have 10 here, so I'm gonna change, or I'm gonna add 10 vertices every time when I hit the space bar, or when it's actually getting called here. Right here. So there you go. So every millisecond I just simply add one more vertex. So it's gonna be, every millisecond. So let's say in 1000 milliseconds, multiply that by 10, you're going to get an interesting number. So let's say 10,000 vertices per second or something. So you get, we create a new vertex with its random position, okay? And I'm multiplying here by 2 and minus 1, so I'm forcing, because next double is returning numbers between 0 and 1, and I would like to grab the numbers between minus 1 and 1, so I had to multiply by 2 and then subtract it by 1, from 1. And once we create a vector, we create another vertex color, which is gonna take, which is actually gonna simply just generate as well. I mean, we're gonna create a new object of that class and generate a random color, and pretty much it. And then when we go to the render, which is called every millisecond, basically, this is how we set it into the settings of the clock timer. I just simply say, okay, just for every vertex you're gonna do, just grab the colors which I've already constructed in here. So item.color.r, G, and B, and then just simply take the position of these vertices which I've created in X, Y, and Z, and just simply plot them or draw them. So at the end you get something like this. You can easily recreate this code, and anyway, I'm gonna try to post this code online so you can just simply download it and play with it. All right. Okay. So if we need to go forward, the last lesson we had, we started to create a cube on the regular classes, and creating a cube is actually quite easy. You just need to know the coordinates for drawing a cube. And I'm trying to okay, can you zoom the screen please? Yes sir. Let me just I'm actually not receiving, by the way, I'm not seeing the chat, so I'm gonna try to figure out a system to do that. I will try to figure out something to do to fix that out. So is it okay right now, Arman? No. Okay. All right. So basically, what you see here, you get this is the constructor of my cube, and each 4 vertices creates a face. Okay. And as you can see here, I'm using the vertex class. Okay, which has the position and the color as well, which contain this information. So it's kind of actually cool because right now you can control the color of every face if you want to, and we can actually start managing it here through the constructor. Now, if you look at the constructor carefully, I've used something which is called the optional parameters. I believe it exists already in C++, but it's already came new in C# and C# 4.0 actually. So basically, you have to write the variable name. Just simply put the equal sign and just simply put the default variable or the default value, excuse me. And it has to be a compile time constant. All right. Actually, last time I tried to do something like this, equal to new vertex color. But of course it won't compile, it will ask you to default parameter value for color must be a compile time constant. So basically null, 1, 2, 3 and all these stuff you're gonna have to pass in. So I just simply said, okay, I will just simply make it null, and if anybody's trying to create a cube by passing only just the size or passing only just the color or passing none, I will start checking out if the color was there or not. If it is there, then use it. If it is not, then just simply initialize a new vertex color, which is right here. As you can see here, everything is 1, 1, 1, so it's going to be a white cube. And let me show you how, in fact, to use F7. How, in fact, to use such a constructor, which is kind of interesting. First of all, in order to show up the cube, I will not need this anymore. Okay, I will just simply just take it out, and here I will just simply take out the generate points. Okay, and right here I'll have a private cube, and because it's not there, we need to have a using. So as you can see here, I have a core lib, and I have folder primitives where I put all the primitive namespace primitives namespace classes right there. So this is the folder doesn't say it is a namespace. It's an organizational method for organizing your sub namespaces, if you will. Okay, so but basically, if you create a folder and just simply add a class inside that folder, the IDE Visual Studio will immediately say it's a sub namespace, and it will take the folder name and stick it out with a dot there. So I will put here as using corelib primitives, and here I'm going to have a cube with a get and set, and right here I'm going to start constructing the cube. So I say cube equals to new cube, and I could just simply close the brackets, and this is it. And it will use the default parameters in order to construct the cube. So cube dot vertices, because a cube has a list of vertices where I just simply add them to the list. I mean, the vertices are being added to this list when the cube is constructed. So if we go back again, view code, I just simply access the vertices, and I will just simply say, oh well, I didn't have to. Geo color 3D, and then I will just simply say item.vertexColor.r. Actually, I could have left it item.vertexColor.g and item.vertexColor.b and geo.geocolor 3D again. Oh no, sorry, vertex 3D, item.position.x, item.position.y, item.position.z, and we are good to go. So if I hit Control F5, let's hope nothing will crash. And as you can see here, I get a very interesting thing going on. And this is for a good reason. Anybody can tell me, oops, not this program, I want this program. Anybody can tell me why I got 4 dots right there? Guys? Can you repeat? Repeat what exactly? The question or? The question. Okay, if I hit Control F5, I get 4 dots right there. Can anybody tell me what did go wrong? Oh well. The epic silence. Okay, can we know? Alright, since nobody would like to share anything and everybody is afraid, so this is because I called in the GL begin, I just said that my drawing mode is GL points, and I should have said GL underscore quads. Okay, if I hit Control F5 and close this guy, then we get ourselves a cube. However, we cannot actually tell very much because it's just a white square. Alright. Now there are a lot of ways of resolving this. One way, which I usually did during the materials, is just simply hook up a keyboard event and just simply rotate it by keyboard. However, I believe Eddie Nagovic that time, he asked me like we need to I would love to like click and drag with the mouse and rotate the thing, which is quite actually easy to do. So I thought, why not just integrating it right off the bat right now? So when you, for example, if I Control F5 again, so if I click and drag, I would love to, like when I click and drag right there, I just would like to rotate the cube sideways, up and down, scroll to zoom in and out, and all these stuff. So it will be nice. Nice feature that it will be allowing you. It will be a lot easier for you, just like to work with your scene here. Okay, So I'll just simply close this little guy, and I will go to my designer, and I will grab my properties, and I will go to my events tab. Now here are a couple things you need to handle. The first thing is you need to know where the mouse has been clicked. So whenever you're trying actually to click and drag, you click down and then you start, dragging, and then you leave your mouse up. Okay, this is what's happening. Okay, so what we need to do is subtract the point of clicking, where you started clicking, from the last point you are on, and this distance, when we subtracted this distance, we just simply multiply it by a small factor, and we push it into our rotation, and this is it. It's as easy as that. There's nothing special or scary about that, about this point. So it's really easy code, and let me show you how this is actually being done. So first of all, we need to record when the mouse has been clicked down. Okay, so I will grab the onMouseDown event, and I will go way up, and I like to organize sometimes my stuff into regions. So I'll just simply say region. This is going to be my temp stuff for now, because it's actually temp stuff, and yeah, as well as the cube, as well as the temp thing. Or let's see, region testing primitives. I'll just move this guy upstairs, and I could just simply collapse this guy so it just gets out of the way. Now here I will just put here a region, global global navigation params. Alright, now as I said already, we would like to grab the initial position, we would like to grab the last position and subtract them from each other in order to get something. So what I'm going to do here is just simply define a couple private variables. So private int initial position, which is fine for now, and private int initial position x and initial position y. So I hope that I haven't made any mistakes. So initial, okay, I'm going to have, and private int, or let it be double control speed, which is going to be like, I will give it a factor of 1. Okay, we can like start putting some fractions in order to minimize it. Well, I believe it will be like 0.9 or 1. Okay, I will leave it at 1 and see what's going to happen. And so we have initial position, yeah, and we need the last one. So last position. So private int last position of x and last position of y. So we got those two, and we need as well 2 rotation parameters. So we need and because I said already we'd like to scroll, like when you scroll up and down, we would love to have we would love to get nearer and farther from the object. So dollying in and out, it's not basically zooming, it's just dolly in and out, because zooming is a different effect. So I'm going to just grab here another variable that's going to be double zoom or dolly speed. I hope that I actually spelled it right. I'll just put it for 1 right now, and later on we're going to change it. Or maybe I'll just simply use control speed. Why not? And instead I will just have a private double dolly. I think dolly is like that. And private rotate, private double rotate x, and private double rotate y. Okay, so because we would like to rotate up and down, so hang on a second, let me control 5. So if you would like to rotate the cube on this axis, not on this axis, on this axis is going to be y. So if you rotate the cube will just go sideways, like it will just simply go from this side to this side. So this is the rotation way. But if you would like to rotate the cube on the x-axis, like a wheel or something like that, then we're gonna have to rotate it on the other side. So I would like to control the mouse when it goes this way. It will just go rotate the other guy. If I just go up, and it will just simply rotate the y-axis. Okay. So I believe I put in all the variables which I need. So initial position, last position, x and y, dollying, speed, out, and so on and so forth. Now, in order to rotate and translate, in order to do all these stuff, what I'm going to do here is just simply specify my zooming in and out. So, for example, it's going to be GL translate or dollying in and out. I would like to, since I'm getting closer and further from the object, I'm getting closer and further on the z-axis. So I'm going to just put 0, 0, and then just simply put the dolly in here. Okay? Because whenever you increment and decrement this, it's going to get you closer and further. If you'd like to test it, -5. And let me close this. There you go. You see the squares became smaller. If you put +5 or let me +1, it's going to be a little bit closer. So you see it became a little bit bigger because you are closer to it. If it's 0, then it's going to be right away from you right there. Okay, so basically we need to put the dolly right in. Now, going further, GL rotate, and now we would like to rotate around which axis. So for example, I would love to rotate around X. I put here the number of degrees, this is the angle. And here I'm going to put the double, so I would like to rotate around X, so it's going to be 1 here, 0, 0. So as you already know from rotation is going to be, this is the vector where you are rotating around, or when you put 1 here, that means I'm going to evolve around the x-axis only. And GL rotate D, rotate Y. It's going to be 0, and because I would like to rotate around Y, I'm going to put 1 here and 0. And semicolon. Okay? Okay, I believe we are good to go, hopefully. Now, this is in terms of what we have to do right here. And if you want to, you could see that I could do something like this. If I put here 45 degrees initially, let's say, right now I'm going to look at the cube from a side, from an upper corner view, like this. Okay. So we can go ahead and even I would even tilt it like 30 or 20 degrees or something like that, so we'll have a little bit of easier look to it. So now I'm rotating around the x-axis, by the way. Okay, let me go forward. Yes, on mouse down. Now it is important to detect which button you pressed. Okay, so you need to know, you need from the user to press the left mouse button. So here I'm gonna have to say if E, I believe it's there you go, E dot button equals system Windows Forms mouse buttons dot left. Right here I'm going to record my initial position, so I say initial position X equals to E dot X, initial position dot equals to E dot Y. And if you would love to, we can grab the forms text, so this dot text equals to initial position X plus initial position Y. So right now on the form text, whenever we click inside, so if I click, oh, vertices count equal to 10. Okay, I need to erase this part, I don't need it. So Control F5 again. So whenever we click here, so I click once, so right now we detect where the mouse is, right? at which point it is. Okay. Now, what we can do with this, I'll just simply take this guy out. It will just simply for debugging purposes. Now, what we need to do is when the user starts to drag. Now, in order to detect that, Shift F7, we need to handle the mouse on mouse move, which is this one. So, occurs when the mouse pointer is moved over the component. So there you go. I need that guy. Now, what we're gonna do is, first of all, we would like to record the last position every time. So every pixel, every point that the mouse moves to, we need to record it. So we're gonna put it into X, so last position X, last position Y equals to E dot Y. And now we're gonna calculate the change every time the mouse moves. So we're gonna have to have int change X equals to last position X minus initial position X. So right now you subtract the last position from the initial position in X-axis and in Y-axis as well. So I'm going to just grab this guy and change this to Y and Y and Y. Alright? And now, again, remember, it's on mouse move, and we have to detect if the button was pressed. So FE dot button equals this guy dot left. Then we're gonna just simply say, okay, the rotate X is gonna be added to it. You know, it depends on wherever you are moving. Change Y. Okay, because when I drag my mouse upwards, you know, your Y value is being changing, and now when we drag our mouse upwards, I would love to rotate my cube into X axis. You will see what I'm talking about in a second here. Once I just finish this code times what would we name our factor variable here? Control speed. So times control speed. What did I do here? Oh, it's an int. It should be, well, oh, why not? I'm just going to change it into a double for now. Okay? And, what did I do? Okay, so, and rotate Y is going to be change in X times the, now I get it. Change, and just simply, and just change. Hang on a sec, guys. Wait a second, I will just pause the recording. Okay, we are back. I don't want to be, yes, everything is just saved. Yes, I'm alive. Believe me, I'm just, hang on a sec, let me try this. No, I cannot drag it outside of the, I cannot drag it anywhere. Hang on a sec, let me see if I can detach it anyway. Hide, minimize, start with, man, I would love to detach this chat window, but apparently it's impossible, and I need it in order for me to keep track of you, and I don't know why I can't. Okay, sorry future guys. Let me just pause the video right here. I will just... Alright, we are back online. I'm really sorry for pausing like several times because we had a problem with the... because it's Saturday and I don't want to be locked out of the faculty, so... and as well we had a problem with the chatting window, so I'm just simply dragging it to another monitor. Right now we are good. Okay, so... what I wanted to do here. So right now we have calculated the last position. So right now we have the ability to calculate where was the mouse and get that length calculated, so we can just simply push it in our rotation. And remember, we always need to pick off as a starting position from the last point we left our mouse button. If you leave it like this, let me see what's going to happen if I'll just simply hit Control F5, and woo, well, that is fast. So it just starts flipping on me. So as you can see here, I'm moving up. It's really fast, I know, and moving down. I'm trying to get it slow. I will just make it slower later. Okay, and whenever you go here and you start again, it doesn't go well. So when you hang on a sec. Let me try to make the control speed a little bit smaller. Control speed, let it be 0.5 for now. So we gotta just make it a little bit slower. It's not even a little bit slower, it's fast still. But anyway, you see, when I move one here, one there, as you can see, it just starts to rotate back again in a very weird way. So I need to always reset my mouse position here. So I'm just gonna say initial position X equals to E dot X, and initial position Y equals to E dot Y. So let's hope it's gonna be good. So there you go. You see? And now even the speed of the mouse is even much better. Are you following, guys? I know I went a little bit fast, so please, if there are any questions, just say it right now. It will be the best. No questions? Sure. Okay. Oh, was I going fast, or was this normal for you guys? Hello? Anybody? Okay. Okay, this is good. This is good. All right. Okay, so since we have our cube right now rotating and responding to our mouse movements, up and down, left and right, so we are good. Now we need to scroll in and out, so to dolly in and out. Now dolly in and out is in fact quite easy. However, you need to detect how much you are scrolling, right? And the problem is the mouse wheel event, you cannot find it here. So if I go to yeah, there you go. So you have on mouse scroll, but this is not it actually. Mouse scroll will not help you out. We need another event that will help you out to detect how much you have been mouse wheeling this thing, so moving the wheel of your mouse. So in order to do that, once the form has been initialized, so after initializing components, I will add here I will manually handle the event of this mouse wheel. So if I say this dot mouse wheel, you see here you go. Here's how to handle an event by your hand. Plus equals new mouse event handler, and right there you pass your delegate, which is your function pointer. I believe you already have seen this in MIS a lot. And here I'm just gonna, for the organization's sake, I will just keep everything nice and neat. I could pass here, by the way, a lambda, and I do all the handling right there. But since I already have the everything is just separated, this is how I handled my events in that way. So I will just will not go into the lambda way. I will just simply make frm main underscore on mouse wheel. So I grab the same like the same spirit or the same like kind of way of how Visual Studio or how C# style of programming in general or generating functions. So here I'm going to have void private void this guy, and of course this guy needs a function which has an object sender, and which is, I mean, an object, whatever you would like to call it, I don't care, and mouse event args e. So the name of the variable doesn't matter, but the main thing is the data types is what matters. And as you can see here, when I got the signature right, everything just went okay. So here what we're gonna do is we need to detect how the mouse wheeling is happening. So if I say this.text equals to e.delta dot to string, okay. So whenever I start to scroll, you will see something quite interesting. Just keep an eye on here. So if I hit scroll, I'm scrolling down right now. So, and I stopped. So this is a scroll down, it gets me minus 120. If I scroll up, it gets plus 120. So basically we need to detect whether you are scrolling whether you are scrolling down or up. So basically if you are scrolling down, this is minus, this is below 0, above 0. So what we're going to need to do, I mean below 0 when you scroll down, above 0 when you scroll up. So what I'm going to do here is just use this idea and put here if e.delta is less than 0, then just simply take my dolly factor and add to it my control speed. Okay, else dolly factor minus equals control speed. So now if I hit control F5, if I scroll away, it goes away from me. If I scroll in, it goes in. So right now you can do all the transformation things you would like to do. Okay? So we have a nice control over here. We can start playing with whatever we do. And it's quite easy. Actually, you can pull this out on any application, not only OpenGL, but you can pull out the same trick on any kind of application. So it's something you could do just for fun. Okay. So now, since we have all these controls in our hand, now time to move along and start creating other interesting stuff. So, as I already mentioned, we have to work with, we're going to work with a little bit with Glut. And Glut is actually quite easy and gives you a lot of stuff that are, a lot of functions that you can use and utilize in order to create things just right out without you have to write your own algorithms for creating them. Like they will create for you, the library will create for you a cube, it will create for you a teapot, a sphere, and so on and so forth. So there are a lot of primitives that come with Glut that you can actually use them and utilize them in your projects if you want to. So, how to work with Glut? Now, if you go over here into the OpenGL demo, I will just simply expand this, and I will try to add it in my usings. But first, let me open this into my Explorer folder. And in my OpenGL demo, I have a dependencies folder. And in my dependencies folder, I've got my DLLs, which is OpenGL, platform, the control, and I've got the library, which is the wrapper, and I've got as well another wrapper, which is FreeGlut. However, you need this DLL library to be there. It has to be, in fact, it has to be right here. It has to be right here, otherwise it won't start. Or you have to put it in Windows/System32 or System64. It depends what's your if you are x64-bit or 32-bit. It depends what's your Windows type. You can just simply paste that DLL right there. However, let me show you how this will be happening. So if I go to references, just simply add a new reference. And as you can see here, okay, because I navigated to it before in another project, apparently it just cached it. So I will just simply, hang on a sec, let me try to see if I'm redirected to the same folder where I want. It's on C actually, so I'm going to grab it from there. References, add a reference, I'm going to browse, and instead I'm going to paste that in. And right here, I'm just, because I'm a different project on my hard drive, so I'm just going to grab this FreeGlut. Whoops, sorry, not this one. Where did I go? This one. So I need to grab this little guy, and I'm going to hit OK. And as any good C# developer, you need to put it in the using. So using tal.glut, FreeGlut in fact. And right after this, which most people forget, after initializing context, you have to say glut.glut or glut init. This initializes your glut context. Now you can call glut functions without having any problems. Now if you hit F5 and run, if it runs then okay, if it doesn't, it doesn't. As you can see here, it says unable to load DLL free glut.dll. So, because it actually refers to it, it's a wrapper that refers to that DLL. So what we're going to do here is Shift F5 and grab this DLL from my dependencies, push it right, oops, here, into the bin folder, into my debug, Control V. Now we have my FreeGlut.dll there. Now if I hit F5 again, my application will work. However, there's nothing interesting happening until now. So what we can do with this thing. Before I actually get started, I forgot to show you the feature about the about this constructor which we have created. So there are two features actually came up with C# 4.0 when it comes to functions and constructors. The optional parameters and name parameters. So if you look here, I have optional parameters, and sometimes some people when they are working, sometimes they forget the names of their parameters, or the order if you will, but they remember them by name. So for instance, let's say I would love to keep the size 1, but I would love actually to change the color. So what you could do here is just simply say color, oops, in small letters, and look at this. C# already giving you, or the IDE is giving you, the IntelliSense is giving you color and colon. And right here, this is how you start pushing in your new whatever object or whatever parameter you would like to push. And right now I didn't have to pass the size first and this guy next. I just simply said, okay, I'm going to access it by name, colon, and then you just simply push in your parameters. So right now, for example, I would like to make my cube as red as it can be. So if I hit Control F5, you get a red cube. However, this is too intense for my eyes. I could get blind, so you need, yeah, open before is fine. Yeah, so it's a little bit darker, a little bit easy in the eyes. All right, and if you want to, you can even put the comma here and just simply put the size, colon, 2. So right now your size is going to be by 2, and as you can see here, I completely ignored the order of the parameters in the constructor, and this is because I used the named parameters feature. So I will just simply leave it at this point, and right now you know how optional parameters and named parameters works in C#. So I hope that you're going to use it in different projects, not even in computer graphics, but in other places. So it's a nice feature to know. Okay, yeah. So getting back to Glut. Now, in order for me to draw this thing, I could just simply, for example, let's say I would love to draw a teapot, which is the most famous example in OpenGL, that you can see a teapot in there for many historical reasons. Probably I'm going to share it with you later one day. But first of all, we would like to position this teapot somewhere away from the cube, because if I right now type in glut.gut solid teapot, and you have to pass in the size, so I'm going to give it 1. Okay. Now the teapot and the cube are going to share the same position, and in fact, you cannot see anything here, but if I put the gl.gl color, well, let it be 0.5, 0.5, 0.8, let's say, I don't know, whatever color that is. Oh, there you go. As you can see here, the cube has shared the same position as this teapot, and the color is very strange, I have to say. 1. Much more visible, although I hate the color, but hey, who cares? So basically, the cube is inside the teapot, so we need to push that teapot a little bit to the side. I could in fact make this teapot black, right? So right now this teapot is completely black, this guy's completely red. Now I could just simply say gl translate, and I will just simply push it into the x-axis. Now since the cube width is 1, and or dimensions, the width and height and everything is 1, and the size of the teapot is as well 1, so 1 to 1, I will just simply push this by factor of 2 at least, 2 or 3, so 2, 0, 0. So this will push it at least right beside, as you can see here, right beside the cube right there. You see, it's exactly beside it. So here is our teapot. Now what I could do as well is show the wireframe above it. So we can, let's say, and since OpenGL is just a simple state machine, we just simply say gl color 3D, and I can just simply switch the colors to white, and I will just simply call the glut not solid teapot this time, but wireframe wire teapot. So, and I will give it not the same size, because the same size you will end up with Z fighting, which two objects occupying the same space, and then you're gonna get this weird flickering and these non-continuous lines. So what I've done here is just simply drawn an object above an object. So what I'm gonna do here is just simply put it like not that far, maybe like 0.05 maybe. It's gonna be good enough. So there you go. You see, it's a little bit, and it's a little bit bigger. So right now, I mean, I need to shrink it a bit. You can see right now it escaped. It became a whole lot bigger than the teapot, the wireframe. So I'm just simply gonna go for probably 2. Yeah. What? 0.01? Come on, that's gonna be. Well, oh well, we could 0.5. Yeah, you will never get it that very good. But anyway, it's quite enough for our purposes, maybe like 9 or 8. You know, it's right now it's a matter of hunting for the number. But anyway, probably I'm not seeing something. And of course, since it's scaled up, you can see it right inside a cube. I'm right now inside the cube. As you can see, it just penetrates it right there. So we need to probably move our cube aside in order to draw this better. So what I'm going to do here is just simply translate 2.5, and we are good to go. Okay. Now, of course, you can pull out all the crazy stuff. You can just simply say glut dot. You have a wire sphere, or yeah, it will be a wire sphere. Who cares? And I'm gonna just simply draw it right before the cube. So I'm just gonna give it radius is gonna be, let's say, 1, or yeah, 1.5 is gonna be a little bit larger than the cube. The slices 10 slices and stacks. I'm gonna show it to you later. Control F5. So as you can see here, yeah, because it's red, because I haven't changed the color, so I'm just gonna go and color it with this. So yeah, right now you can see it in white. And if you look at the sphere like this, like so, the vertical ones are the slices. Okay, the vertical ones, these are called the slices. And the horizontal ones are called the stacks. Okay. Yeah, so this is pretty much it. All right. Of course, you can pull out other stuff. You have GLUT, octahedron, tetrahedrons, and all these stuff. But I believe it's somewhere. Yeah, it's wired. Did I create a wireframe of it? I will just simply change this to solid. Solid, yeah, okay, whatever. I'm just picking up anything right now. But when I get this way interesting blob. Now, this is, I mean, right now you can come up with anything you can think of, and you can actually use these objects, position them around, and you can get interesting effects going. Alright, so this is basically how to set up our scene to be able to move with the mouse, scroll in and out, and even positioning a wireframe object over a solid object to appear that it's as if it is like one object, so it could be useful for you in case of debugging or something like that. And on the next session, we're going to move on and start working on something a little bit more interesting. So I will pause this. This is going to be the end of this first session. The next session we're going to start on after the break. Okay, so see you in the next session.